Hi everybody and welcome to today's Saturday session with Exam Revision. So this is going to be for Leaving Cert higher level maths students, and what we're going to focus on is how simultaneous equations can be asked as part of algebra. Okay, so for your Leaving Cert there are two new types of simultaneous equations that can come up. They're a paper 1 topic. They come up quite regularly, as we'll see. And they're very important skills. They will come up later on in your course as well. This is something you'd usually do fairly on in 5th year, but there is overlap as well that we will discuss later on when we get to that. So I'm going to divide this session up into 3 sections. So very briefly, we're going to revise the simultaneous equations you would have done for junior cert. So if you are unsure of these, watch me do my example, and then if you're still unsure after that, I really strongly advise you going back and trying a few on your own, just because we're going to need that for the Leaving Cert style ones. Okay, then the second 2 things there in the learning intentions are for your Leaving Cert. So you need to be able to solve systems of 3 simultaneous equations. So here we're given 3 equations. There'll be 3 unknowns, so maybe x, y and z, or a, b and c, and you'll have to solve for all 3 of them. And the second type of new simultaneous equation then that can come up is your linear and non-linear simultaneous equations. Okay, so very quickly, this is how it would have come up in your junior cert. Okay, so here the question would say solve. Okay, by solve here we want x equal to something and y equal to something. Okay, now for any simultaneous equations, what we want is we want to pick a letter. So I'm going to go with y's here. And we want the coefficients or the number in front of the y's to be the same number but of opposite signs. That way they're going to cancel out. So I see here I have a 4y and a minus 3y. So they already have opposite signs. I'm happy about that. But I need them to have the same number. Okay, so I have a 4 and a 3. I can make them both into positive 12y and negative 12y. So to make this into a 12y, what I'm going to do, I'm going to multiply this whole line by 3. So it's going to be 9x plus 12y is equal to 18 by 3, which is 54. Now the bottom line, I want to turn that negative 3y into a negative 12y. So I need to multiply that line by 4. Very important to multiply everything in the line. So it's going to be 16x minus 12y is equal to minus 4. Now, cancel out. So 9x plus 16x will be 25x is equal to 54 minus 4, which will be 50. Get x on its own, divide both sides by 25. We get that x is equal to 2. So that's one of my answers. Now I need to solve for y. So I'm going to take my top equation. And I know that x is 2. So it's going to be 3 multiplied by 2 plus 4y is equal to 18. 6 plus 4y is equal to 18. Subtract 6 from both sides. Divide both sides by 4. We get that y is equal to 3. Okay, now as I said, that is a very quick run through of what you would have done at junior cycle. If you are unsure, please stop this video now and go do some more work on that and then come back to the video. Okay, that is it comes up in various topics, those type of simultaneous equations for your Leaving Cert, but usually as part of a longer question. Okay, we're going to move on now, and this is the new type of simultaneous equation. So the first new type that you need to know for your Leaving Cert. So in this simultaneous equation, you'll notice we're given 3 equations and we're missing 3 unknowns. Okay, so we're looking for x, y and z. Now I like to keep these nice and structured. The maths in this is not particularly difficult, but there is a lot of organisation involved in it. So I'm going to use a few subheadings. I'm going to structure them the same. We're going to do 2 or 3 examples of this. We're going to structure them all the same, just to keep our work nice and organised. Okay, so first I'm going to label my equations as 1, 2 and 3. Okay, now first I'm going to take equations 1 and 2. And I'm going to look at what variable or what letter I'm going to choose to cancel. Okay, I'm going to go with z's. And I'm going to write down what I'm going to cancel. Okay, you'll see why later on. So I'm going to work with equation 1 and 2, very similar to what you would have done at junior cert, and I'm going to make the z's cancel. Okay, can see they have the same number in front or the same coefficient in front, but they have the same signs. So to get them to be opposite signs, I'm going to multiply all the bottom line by -1. So leave the top line alone. I'm going to multiply the bottom line by -1. They'll cancel. So now we have 2x minus x will give me x, just 1x. 3y plus y will be 4y is equal to 6. Now, I'm going to get out a highlighter and I'm going to put a big circle around that. That is going to be super important later on, and I'm actually going to label that as equation 4. Okay, that's my step 1 done. Now for step 2, instead of taking equation 1 and 2, what I'm going to do is I'm going to take equation 2 and 3, and I'm going to cancel z again. Okay, so whatever you chose to cancel over here, you have to cancel the same variable or the same letter in your second step. Okay, so I'm going to write down equation 2 and 3. So x minus y plus z is equal to -4, and x minus 2y minus 2z is equal to 2. Okay, I want my z's to cancel, so I need to make that top line a positive 2z. So I need to multiply that top line by 2. So 2x minus 2y plus 2z is equal to -8, and leave the bottom line alone. Z's will cancel. 2x plus x will give me 3x. Minus 2y will be minus 4y is equal to -8 plus 2 will give me 6, -6 even. Okay, and I'm going to call that equation 5. Okay, again, I'm going to highlight it because it's super important, and it's going to be used in our next step. So we've done 1 and 2 and we've cancelled z. We've done 2 and 3, we've cancelled z. Now we're going to take equation 4 and 5. So we have x plus 4y is equal to 6, and 3x minus 4y is equal to -6. Now, what I was saying earlier about your junior cert to simultaneous equations being very important, we are now back to a junior cert simultaneous equation. Okay, here we need to pick something to cancel. If you look at this, you'll actually notice, or should notice, that the y's are cancelling automatically. It won't always work like this, but nice and handy here, we can just cancel them out. So we're left then with 4x is equal to 6 minus 6 will be 0. Divide both sides by 4. We're going to get that x is equal to 0. Okay, I'm going to put a big highlight on that as well, or put a box around it. That is your first part of your answer. So we've solved for x. Now what we're going to do is we are going to take either equation 4 or equation 5. I'm going to go with equation 4. We know x is 0. So I'm going to replace x with 0. We are then left with 4y is equal to 6. Divide both sides by 4. We get that y is equal to 6 divided by 4 into your calculator, and we'll give you 3 over 2. Okay, if you wish, you can change that to 1.5. I'm just going to leave it as a fraction there. So that's my y. And now we found our x, we found our y. All we're looking for now is z. So what I'm going to do is I'm going to take equation, pick whichever you want, 1, 2 or 3. I'm just going to go with equation 1. So we have 2x plus 3y plus z is equal to 2. We know x is 0. We know y is 3 over 2. And we don't know what z is equal to 2. Now 2 multiplied by 0 will be 0. 3 over 2 multiplied by 3 over 2 multiplied by 3 will give me 9 over 2. Plus z is equal to 2. So we've got 9 over 2 plus z is equal to 2. Z is equal to 2 minus 9 over 2. Z is equal to minus 5 over 2. If you want to work with decimals there, if you find decimals easier to work with, that would be fine. They're all nice decimals anyway. So we've solved for x, y and z. There are 3 answers for that question and your final answers. As you can see, it's quite long. Nothing particularly difficult. It's just remembering the steps, but with enough practice, the steps should kind of start coming naturally to you. Organisation is key. When we do the next example, it's going to be quite similar. but we're going to keep the headings, keep things nice and neat to limit some mistakes. Okay, so we're going into our exam questions now. This came up in 2022. Now, I thought there was two kind of tricky bits about this. You'll notice when you read this question, the areas of the three regions, K, L and N, we don't know anything about that. I've taken this from a much longer question. But regardless of that, we should still be able to spot. We're asked to solve the equations. There's three equations, three unknowns. This is very, very similar to the last example we just did. Okay, so I'm going to label these first, as I did the last time, as 1, 2 and 3. I'm going to take 1 and 2 first, and I'm going to cancel. Now, it's always worth taking a look at your equations to think which is the easiest to cancel. Immediately jumping out at me there is to cancel C's, because they all have the same coefficient or the same number in front of them already. We'll just have to work with the signs. Okay, if you did decide to cancel B, would be the next easiest option. You will get out the same answers. Your work will look completely different the whole way down, but your answers should be the same. So 4A plus 3B plus 3C is equal to 807. And we have 28A plus 9B plus 3C is equal to 879. Now I want these to cancel, so I'm going to multiply the bottom line by -1. It'll be negative 28A minus 9B minus 3C is equal to minus 879. Now, other than recognising that this was just a normal simultaneous equation, the second difficulty is the size of the numbers. Now, you have calculators. It shouldn't really be a reason to make a mistake, but slips, I guess, are a little bit more likely. So we have 4A minus 28A, that's going to be minus 24A. 3B minus 9B, that'll be minus 6B. Cancel the C's, is equal to 807 minus 879 will be minus 72. Okay, again, we're going to highlight that, because we're going to need to come back to that, because there's so much writing, things can easily get lost on the page. And I'm going to call that equation 4. Now I've done 1 and 2. Next thing I'm going to do 2 and 3. And I'm going to cancel C again. Okay, you could also do 1 and 3 there if you prefer. Okay, cancel C's again, just need to multiply the bottom line by -1. Okay, C's will cancel. 28A minus 76. A will give me minus 48A. 9B minus 15B will give me minus 6B. Is equal to, now, sorry, there's no minus sign there. I don't know where that appeared from. So 879 minus 663, that's going to give me 216. And I'm going to call that equation 5. Okay, so you should notice steps, I'm copying them exactly the same, keeping things nice and organised using my headings. Next, I need to take 4 and 5. And then this is just a junior cert simultaneous equation. So we have minus 24A minus 6B is equal to negative 72. And we have minus 48A minus 6B is equal to 216. Now, the B's here are going to be easier to cancel. They already have the same number in front, but unfortunately the signs are the same. So they don't cancel the way they are now, but I'm going to multiply all the bottom line by -1. So leave the top line alone. And 48A plus 6B is equal to minus 216. B's will cancel. We have minus 24A plus 48A. That's going to give me 24A. Sorry, positive 24A is equal to minus 72 minus 216. That's going to be minus 288. Divide both sides by 24. We get that A is equal to minus 12. Okay, that's one of my three answers. Now we're going to take equation 4, and instead of writing A, we can sub in minus 12. Okay, negative 24 multiplied by minus 12 is going to give me 288. Minus 6b is equal to minus 72. Subtract 288 from both sides. So minus 6b is equal to minus 360. Divide both sides by minus 6. We get that b is equal to 60. That's answer number 2. And finally, we need to solve for c. I'm just going to take equation 1. You can take equation 1, 2 or 3, whichever you want, which says that 4a plus 3b plus 3c is equal to 807. We know what a is. We know a is minus 12. We know b is 60. We don't know what c is. So 4 multiplied by minus 12 plus 3 by 60 gives me 132. Plus 3c is equal to 807. So I just have to move down here just to get an extra bit of space. So 3c minus 132 from 807 is going to give me 675. Divide both sides by 3. C is equal to 225. Okay, so I hope you realise, I guess, how important the structure is and how similar that question is to our first example. Numbers a little bit awkward. We actually got out really nice numbers at the end. But I guess a little bit more daunting with the bigger numbers. Okay, so that was the 2022 question. We're going to move on now and do the 2018 question. Okay, so this was nice, straightforward. It told you that this is a simultaneous equation. I guess a little bit of a trick involved here. Okay, there's something that's standing out to me immediately. So I see that the first two equations look fine. This bottom one, the third one, looks a little odd. Okay, there's no y there. What I'm actually going to do, instead of having the gap, I'm just going to say plus 0y. And now suddenly it looks like a normal simultaneous equation like we had been doing. So I'm going to label these as 1, 2 and 3. And we're going to go off and we're going to start again. Now, if you want to work ahead of me and see how you get on, I'm going to cancel z's. So first I'm going to do equation 1 and 2. And I'm going to cancel z. And then I'm going to actually do equation 1 and 3. And cancel z, okay? Just to show you don't always have to do 1 and 2 and 2 and 3. Different combinations will work. But the important thing is I'm cancelling z's in all of those first two steps. Okay, so if you want to pause, give it a go, and then resume the video to see how you got on. So we're going to take 1 and 2 and cancel z. So 2x plus 3y minus z is equal to minus 4. And 3x plus 2y plus 2z is equal to 14. Cancel z, so you want to make that first line to have a minus 2z. So we're going to multiply the whole top line by 2. Oh, sorry. What did I forget to do there? To multiply the other terms by 2 as well. And we can leave the bottom line alone. Okay, z's cancel. We've 4x plus 3x, that will give me 7x. We have 6y plus 2y is 8y is equal to minus 8 plus 14, which will be 6. I'm going to call that equation 4 and just highlight it so I don't lose it. So that's my first step done. And now I'm going to do 1 and 3 and I'm going to cancel z's with those. So we have 2x plus 3y minus z is equal to minus 4, and x plus 0y minus 3z is equal to minus 13. Okay, I need to cancel z's again, so I need to multiply that top line by negative 3 to get a positive 3z. So it'll be minus 6x minus 9y plus 3z is equal to positive 12. And the bottom line, leave it alone. Okay, the z's will cancel. So we have minus 6x plus x, which will give me minus 5x. Minus 9y plus 0y will give me minus 9y is equal to 12 minus 13 will be minus 1. I'm going to call that equation 5. So that's step 1 and 2 done. Now, next thing, we have our new equations 4 and 5, so we're going to work with those as if they were junior cert ones. And we're going to be able to solve for one thing. So we have 7x plus 8y is equal to 6, and we have minus 5x minus 9y is equal to negative 1. Now here, we need something to cancel. I'm going to cancel the x's. We have a 7 and a 5. I can make those both 35. So if I multiply the top line by 5 and the bottom line by just by 7, because the signs are already different. Top line by 5, that's going to give me 35x plus 40y is equal to 30. And the bottom line then by 7 will be minus 35x minus 63y is equal to minus 7. X's cancel. 40y minus 63y, that's going to give me minus 23y is equal to 30 minus 7 will be 23. Divide both sides by minus 23. Y is equal to negative 1. Okay, one of my answers. Now we take equation 4 and we'll sub in what we just found out. So 7x plus 8 by minus 1 is equal to 6. 7x minus 8 is equal to 6. 7x is equal to plus 8 to both sides will give me 7x is equal to 14. Divide both sides by 7. We get that x is equal to 2. And then finally, we need to pick one of the original equations. I'm actually going to go with equation 3 here to solve for z. It doesn't matter. Pick 1, 2 or 3. I think in the last two examples we picked 1, but just to show you can pick any, I'm going to sub it into 3. So we have x plus 0y minus 3z is equal to minus 13. We know x is 2. We know y is minus 1. Okay, so 2 plus 0 by minus 1, 0 multiplied by minus 1 is 0. So we're actually just left with 2 minus 3z is equal to minus 13. Subtract 2 from both sides. We're left with minus 3z is equal to minus 15. Divide both sides by negative 3. We are left with z is equal to 5. So my three answers are x is equal to 2, y is equal to minus 1, and z is equal to 5. Okay, to be nice to your examiner or your teacher, make your answers nice and clear. Even maybe list them at the end, just so if you have it right straight away, nice and easy to correct for your teacher or for your examiner. Okay, so that was the 2018 question. Just that small trick at the start to put in that plus 0y, and then we were back to normal. Okay. So the last type of these simultaneous equations that we're going to look at is the 2013 exam question. At first glance, this may look a little bit daunting. I think the first thing most students would see here is the fractions and think, what are we going to do with the fractions? You could work away with the fractions and do this as normal. I think it would be a nightmare. I think you're much more likely to make a mistake with the fractions. Like if you need to multiply the fractions, I just think you're more likely to make a mistake. What I'm going to do instead is I'm going to turn this into a question with no fractions, and then I can continue as I've been doing all the other examples. Okay, so with this one here, Okay, I want to get rid of that 5 over 2. I don't really want a fraction in my question. So to get rid of that 5 over 2, if I multiply 5 over 2 by 2, the fraction's going to be gone. I'm going to be left with 5. So if I multiply this whole line by 2, 5 over 2 multiplied by 2 is 5. Y multiplied by 2 is 2y plus 20z is equal to 80. No fraction left. I'm going to do the same thing with the bottom one. Okay, so equation 3. Well, again, because there's a 2 on the bottom of the fraction, I can multiply the whole line by 2. So it'll be 4 x plus a half multiplied by 2 is going to just give me y plus 8z is equal to 42. Okay, now I have my equation 1, 2 and 3. No fractions involved, so I can continue as normal. Okay, so I'd encourage you, now that we've done a few, to give this a go. What I'm going to do equation 1 and 2, and I'm going to cancel y. And then I'm going to do 1 and 3. And I'm going to cancel y. Okay, if you want to follow along with the steps that I'm going to do, if you decide to, you can very easily cancel x's here as well. Okay, your question will look different the whole way down from mine, but your final answers should be the same. Okay, I could give this question to 10 people in a class and everyone might do it slightly differently. So some people might choose to cancel y's, some might choose to cancel z's or x's. Some people might do 1 and 2 and then 2 and 3, or 1 and 3 and 2 and there are loads of different combinations. Okay, at the end of the day, everyone should get the same answer. Sometimes certain options are easier than others, but every option will work provided you make no little slips as you're going through it. Okay, so off we go. 1 and 2 and cancel y. So it's x plus y plus z is equal to 16, and okay, need y's to cancel, so I'm going to multiply that top line by -2. Okay, y's cancel, -2x plus 5x will give me 3x. Plus -2z plus 20z will be 18z. Is equal to, sorry now, and I've just made a very common error there. I never multiplied this 16 by -2, so that should be -32. Okay, probably the most common mistake that is made in these. You'll just make a little slip. People tend to know the structure very well, but you can see there how easy a little slip is. So -32 plus 80 will give me 48. Okay, marked that off as my equation 4. Okay, now I'm going to do 1 and 3 and cancel y. So again, x plus y plus z is equal to 16. And equation 3 without the fraction is 4x plus y plus 8z is equal to 42. To get something to cancel, I need a positive y and a negative y. So I'm going to multiply all the bottom line by -1. Okay, so x minus 4x is -3x. Y's will cancel. Z minus 8z is -7z is equal to 16 minus 42 is -26. And that's my equation 5. Okay, now that I have equation 4 and 5, I'm going to work with the two of those. And I'll be able to solve for one thing. So we have 3x plus 18z is equal to 48, and minus 3x minus 7z is equal to -26. Okay, now this is, I guess, best case scenario. We actually don't have to do any work here. The x's cancel by themselves. Okay, and then we're just left with 18z minus 7z. That is going to give me 11z is equal to 48 minus 26, which gives me 22. divide both sides by 11, z is equal to 2. There's my first answer. Now we need to find x. What I'm going to do, I'm just going to take equation 4 and I'm going to sub in what I know. So we have 3x plus 18, and instead of z I can write 2 is equal to 48. Minus 36 from both sides. We get that 3x is equal to 48 minus 36, which is 12. Divide by 3. X is equal to 4. My second answer, and now use one of your original equations. I'm going to go with 1 because it's just the most straightforward. 1 tells us that x plus y plus z is equal to 16. We know x is 4. We don't know what y is yet, but we know z is 2. So 6 plus y is equal to 16. Minus 6 from both sides, y is equal to 10. Okay, so there, once you got over the, I guess the initial challenge of the fractions, the question actually worked out extremely nicely. That's the end of this section, so that's the last of those questions. If they come up, they tend to kind of throw in a little trick. So like this one, the 2013 one with the fractions, or the 2018 one without the y here. Or I guess the 2022 one where the numbers are really awkward and it didn't really say simultaneous equations. You had to kind of figure that out for yourself. But in general, once you do a bit of practice at this, the steps will become kind of natural to do. You'll just know how to progress from one bit to the other, as long as you just keep your work nice and organised. So that's the end of the first new type of simultaneous equation that you need to be able to do for your Leaving Cert. So in a second now we're going to go on and we're going to do the next types, the linear and the non-linear simultaneous equation. So the last section of this video, linear and non-linear simultaneous equations. Again, new for Leaving Cert. This is the part that overlaps with coordinate geometry if you were asked to find the point of intersection of a circle and a line. Now, if you're in 5th year, you won't have covered that yet. But just keep in mind, this is going to be coming up again. Okay, and if you're in 6th year doing your revision, tick both of these off in the same revision session. Okay, so this is for finding the point of intersection of a circle and a line, or it can that would be a paper 2 question, or it can come up in paper 1, just straightforward, solve the simultaneous equation. Okay, now immediately what you'll notice with this, okay, top equation looks fine. Okay, we kind of know how to do something with that. Bottom equation, you see we've squares. Okay, so you see this x squared and y squared. So what you're looking for here, the first step with this is we need to realize that this is linear. So there's no squares. Okay, so what linear means if you graph it, it would be a line. But we're not going to go into that. Right now, linear just means one with no squares. No x multiplied by y, or kind of anything weird. Okay, then this is our non-linear. Okay, which can have squares, so like x squared, y squared. It could have x multiplied by y. So that's our non-linear. So that's our step 1. Figure out which is your linear and which is your non-linear. Okay, our real step 1 then. So what I'm going to call a step 1, I'm going to rearrange my linear. Okay, so we currently have x minus y plus 3 is equal to 0. Now, when I rearrange it, what I want is I want either the x or y on its own. Okay, so I want x equal to something or y equal to something. Okay, you would have probably done this when you were kind of looking at manipulation of formula for junior cert, or you would also be doing that in algebra for Leaving Cert. So I want x on its own. What I'm going to do is I'm going to plus y and minus 3 to both sides. So that is rearranged to be x is equal to y minus 3. Okay, rearranged it to get either x or y on its own. There, I just went for x. Okay, that is your step 1. Our step 2 then, we're going to sub that into our non-linear. Okay, so right now our non-linear is x squared plus y squared plus 2x minus 4y plus 3 is equal to 0. From step 1, we found out that x is the same thing as y minus 3. So everywhere we have an x, I'm going to put in y minus 3. So instead of writing x squared, I'm going to write y minus 3 to be squared. Just make sure you put it in a bracket. Plus y squared. Here again, plus 2x or plus 2x. Instead of x, we're going to do y minus 3. Is equal to 0. Okay, so you take your step 1 after you've rearranged it, then you go to your nonlinear, and we found that x was y minus 3, so everywhere where there's an x in our nonlinear, we're going to replace it with y minus 3. Now, a super common mistake that people make, and I'm going to multiply this out to the side because it is such a big problem, or something that students just find so difficult. I need to square y minus 3. Now, there is a shortcut in how to do it. I'm not going to get into that. What I'm going to do it the way you would have done it for junior cert, or the way I teach it for junior cert. So y minus 3 to be squared is y minus 3 multiplied by y minus 3. So now it's going to multiply out those brackets. Okay, so what I'm going to do, write down the second bracket twice, split up the first bracket, multiply that out. I get that y minus 3 to be squared is y squared minus 6y plus 9. Okay, the most common mistake people make with these questions is that they'll say y minus 3 to be squared, and don't write this down. They will say that that's y squared plus 9. They'll just square the two parts individually, and unfortunately you will not get anything for that. It is not how you do it. So there is a shortcut as well of how to square that out. If you know that, great. If you don't, I would say just do this nice and quickly. Okay, or whatever way you would have multiplied out two brackets for junior cert, you may also have done it like this. As long as you get the same answer, we're on the same page. Okay, so we still then have y squared. Going to multiply that 2 into the bracket, so 2y minus 6 minus 4y plus 3 is equal to 0. Now I'm going to tidy this up. So I have y squared plus y squared, that'll be 2y squared. Minus 6y plus 2y will be plus 4y. Oh, sorry, I also have minus. Sorry, 1 second. That is not right. So I have minus 6y plus 2y. That gives me minus 4y. And we have another minus 4y. That's minus 8y. Once you count up all those y's. And then we have 9 plus 3 will be plus 12. Sorry. Nine minus 6 will give me 3. Plus 3 will give me plus 6. Is equal to 0. Okay. Now, from here, you have a few different options. Okay. That is a quadratic. There are two different ways to do it. You can factorize. Okay. Factorizing will work for this, or you can use the minus b formula. I guess with these questions, there is a lot of prior knowledge required for it. So even here, like squaring out the brackets is a skill in itself, and either factorizing or the minus b formula here is also a skill. I haven't revised them in this video, but if you are rusty on them, it's kind of something you need to take a little bit of responsibility for and just revise from your junior cert. In the long run, if you spend half an hour revising for that, it will really benefit you. The minus b formula is something you need to be super confident with for all chapters. So if you have a problem with that, fix it now rather than later. I'm going to do the minus b formula here. So very quickly, I'm going to write it down. Okay, a is always the number in front of the squared. So a is equal to 2. B is the number in front of the variable with no power. So it'll be minus 8, and c is the constant. Okay, I'm going to fire that into my formula. So it's going to be minus 8 plus or minus square root of minus 8 squared Okay, now I put this all straight into my calculator, obviously with the plus first, and then I change the plus to a minus. Just very careful here. If you notice, we have y's in our equation. So when we solve this, it's going to be y is equal to something and y is equal to something. I think just from habit at junior cert, we always kind of use x as a junior cert. You always presume you're solving for x. just go back up to your quadratic, see what variable or unknown is there, and that will be your answer. So I'm going to put that straight into my calculator. And I get out y is equal to 3. When I have the plus in front of the square root, and when I put a minus in front of the square root, I get y is equal to 1. Okay, so a few important points here. Number one, there is a lot of extra skills involved. Squaring out a bracket, almost guaranteed to come up in these questions. It is almost guaranteed to come up somewhere on your paper. Very important skill. Point number two, you need to be confident with the minus b formula. If you are struggling with it, stop now, go back and revise it. Okay, it's going to come up in all of these. Okay, and then I guess the final point, just make sure you know if you've solved for x or solved for y, just look back up at your quadratic. Was there x's or y's in the question or in the equation? So that is actually 2 of my answers. So I've solved the equation for 2y's. So we have y is equal to 3 and y is equal to 1. Okay, for this, we are actually going to end up with 2 sets of answers. So we're going to have 2 values for x and 2 values for y. Now, step 3. Okay, what we're going to do is we're going to take this equation. So we have x is equal to y minus 3. We've just found out that y is equal to 3 or y is equal to 1. What we're going to do, we're just going to sub those in. So we have x is equal to y, which is 3 minus 3. We get out x is equal to 0. Or x is equal to y, which is 1 minus 3. X is equal to minus 2. And they are our second set of answers. Okay, so our final answer, x equal to 0, y is equal to 3. Or x is equal to minus 2, y is equal to 1. They are both valid sets of answers. And at the end, I would just kind of write them like this, just to pair them up. Okay. In general, people tend to make small mistakes with these. Just work through them nice and slowly. We're going to look at another 1 or 2 examples now, just to practice. But again, just if you are rusty on your multiplying out brackets or your minus b formula, maybe go over those before we go on to the next example. Okay, so this one is from 2016, solve the simultaneous equations. First thing that I notice when I look at this, I see the top equation has squares in it and x, y's and weird things. So I'm going to immediately write nonlinear beside that. And that means my bottom one then is my linear. Okay. Now, the first thing that you're going to notice when we get into this question is there is going to be quite a lot of fractions involved. With the, I think was it the 2013 simultaneous equation where there was 3 of them, we were able to get rid of the fractions. We won't be able to here, but we'll get to that when we see it. So step 1, we're going to rearrange the linear. So my linear is 2x plus 3y is equal to minus 1. Need to choose to get x or y on its own. I'm just going to go with x on its own. So I need to subtract 3y from both sides. So I'm left with 2x is equal to minus 1 minus 3y. Don't want 2x, I just want x. So I need to divide everything by 2. Okay. Now, I can't, if I multiply all that by 2 to get rid of the fraction, I'm going to end up back up here. I'd just be going around in circles. I need just x or just y on its own. So that is what I have to do there. I'm going to leave them as fractions. You could potentially use decimals here as well, but in the long run, you have to get comfortable working with fractions. So we're going to stick with the fractions. That's step 1 done. Step 2 then, we're going to sub this guy here into my non-linear. Okay, so my non-linear, I'm just going to write it down here so I have everything together, is x squared plus xy plus 2y squared is equal to 4. And I know instead of writing x, I can write minus a half minus 3 over 2y. to be squared. Plus xy, so plus x, which is minus a half, minus 3 over 2y, all multiplied by y. Remember, this y is still here. Plus 2y squared is equal to 4. Now, I'm going to go off to the side and I'm going to square out this bracket. Okay, so I'm going to write it out twice. Write down the second bracket twice. And split up the first bracket. Okay, this is messy, so just nice and slowly. Minus a half multiplied by minus a half is going to give me a quarter. Minus a half multiplied by minus 3 over 2 is going to give me positive 3 over 4 y. Then we have minus 3 over 2 multiplied by minus a half again, which will give me another 3 over 4 y. And then we have minus 3 over 2 multiplied by minus 3 over 2, which is going to give me plus 9 over 4 y squared. Okay, tidy that up. That's going to give me 1 over 4 plus 3 over 4 plus 3 over 4. That's going to give me plus 3 over 2y plus 9 over 4 y squared. Okay, I suppose just what to keep in mind here, this is no more difficult than if they were nice numbers, if you take your time with it and just be that little bit more careful. Okay, so instead of writing this bracket here, I can write that as 1 over 4 plus 3 over 2y plus 9 over 4 y squared. Then we have to multiply this bracket by y, so it's going to be minus a half y minus 3 over 2y squared plus 2y squared is equal to 4. Now, I'm going to be able to tidy this up a little bit, so any of the y squareds I'm going to add together. So you have 2y squared plus 9 over 4y squared. That gives me 11 over 4 y squared. Add all the y's together. So I have 3 over 2y minus 1 over 2y. That's actually just going to give me 1y. Is equal to, and then the numbers. Alright, so the numbers I just have plus a quarter is equal to 4. For, we're going to end up using the minus b formula. For a quadratic, we need everything at the same side of the equal to sign. So it'll be 11 over 4 y squared plus y, 1 over 4 minus 4. I'll bring over that 4, it'll be minus 15 over 4 is equal to 0. Now, from here you have two options. You can leave it at that, so use those numbers to the minus b formula. It will work. But here we can actually multiply across by 4, and that will get rid of the fractions for us. So multiply everything by 4. That will give me 11y squared plus 4y minus 15 is equal to 0. Multiplied by 4 is 0. And I can use that in my minus b formula. So minus b plus minus square root b squared minus 4ac all over 2a. A is equal to 11, b is equal to 4, c is equal to minus 15. Okay, so sub that in. So I would really encourage you to be working through this either with me, pause the video, and just make sure you can use your calculator. It is a little bit annoying if you keep making mistakes on your calculator doing this, because it is a lot to be getting into your calculator. Okay, so first I'm going to press the plus button in front of the square root, then I'm going to press the minus button. So I get out one answer of 1. Now be careful, is it x is 1 or y is 1? Up in my quadratic I had y's, so my answer is going to be y is equal to 1. Or go up and change that minus or that plus sign in front of the square root to a negative sign. I get out minus 15 over 11. Okay, I'm not going to change that into a fraction or into a decimal, because if I do, it is a reoccurring decimal. It'll be minus 1.363636 and so on. So just leave that as a fraction. Okay, that's step 2 done. For step 3 then, I'm going to take my step 1 and I'm going to take my 2 answers for y, so y is equal to 1 or y is equal to minus 15 over 11, and I'm going to sub them in. Okay, so I get out one answer there. When I sub that in, I get out x is equal, sorry, what did I write down? Y, that should be x is equal to minus 2. And when I sub in my minus 15 over 11, I get out that x is equal to 17 over 11. Okay, so my 2 sets of answers then, x is equal to minus 2 and y is equal to 1, or x is equal to 17 over 11, y is equal to minus 15 over 11. Okay, now I would consider that quite challenging. There is a lot of different algebra involved in it. Okay, take your time, lay it out nice and neatly, but also remember, if you do make a small mistake, okay, which I'm sure when this came up in 2016, lots of people did make small mistakes going through it. If you have the correct steps and the correct structure and you are, I guess, making a good attempt at it, there are quite generous attempt marks being given for that, okay? Especially when the questions get a little bit awkward. If you are working through it, you're going to pick up some attempt marks, okay? So even if you get awful answers at the end, you kind of know are wrong, don't be too disheartened by it. Okay, so the last one we're going to do now is from 2012, and this is a little bit nicer. Okay, I think that 2016 one was the worst one that came up in a while, just because of its awkwardness. This is a little bit nicer. Okay, so what I encourage you to do, maybe pause it and try the whole thing yourself, and then resume the video, and I will go through it. So first things first, again, label our linear, which is the one without the squares or the ABs or anything. And then the top one then is my nonlinear. Okay, so first step 1, we're going to rearrange linear. So it's currently a plus 2b plus 1 is equal to 0. I'm going to get a on its own. So a is equal to minus 2b minus 1. And for step 2, we're going to sub that into my nonlinear. So my nonlinear at the moment is looking like a squared minus ab plus b squared is equal to 3. Everywhere there's an a, replace it with minus 2b minus 1. Okay, now again, just nice and slowly with this, I'm going to take this off to the side and I'm going to square it. Okay, if you can do this quicker, great. But in my opinion, it's not worth taking a shortcut and making a mistake. Okay, so I get out, when I square that out, I get out 4b squared plus 4b plus 1. Now, be very, very careful here. There is a minus sign here, and you're multiplying in a b as well. So we're going to take this nice and slowly. So we're going to multiply b by minus 2b. That's going to give me minus 2b squared. And then we have a minus here, so minus 2b squared will be plus 2b squared. Okay, and then we have b multiplied by minus 1, which is minus b. And we have this minus here, so that's actually going to be plus b. Plus b squared is equal to 3. Okay, very tricky there that this minus sign was here. Just be careful. B multiplied by minus 2b is minus 2b squared. Minus by minus will give me a plus then. Okay, tidy this up, make it look like a quadratic. So how many b squares do we have? 7b squares. And you do 4b squared plus 2b squared plus b squared. How many b's? We've got plus 5b. Plus 1 is equal to 3. To make it a quadratic, that we can use the minus b formula on. Everything to one side. So 7b squared plus 5b minus 2 is equal to 0. And now pop that into your minus b formula. So we have a is equal to 7, b is equal to 5, and c is equal to minus 2. Now, be careful. I know there's b's here in the question as well. Just try not to get confused. They do that, I think, on purpose to try and catch you out. But we should be okay. So it'll be minus 5 plus or minus square root of 5 squared minus 4 by a, which is 7, by c, which is minus 2, all over 2 by 7. Into your calculator, put the plus in front of the square root first. And we will get out now. Two over 7. So it's b is equal to 2 over 7. How do I know what letter? It's because in my quadratic I had b's. Or when I put the minus in front of the square root, I get out b is equal to minus 1. Okay, so there are two of my answers. Now I'm going to go up here for my step 3. I'm going to take this rearranged equation where I said that a is equal to minus 2b minus 1. I'm going to bring up my two answers. So b is equal to 2 over 7 or b is equal to minus 1. Okay, sub them in. So a is equal to minus 2 by 2 over 7 minus 1. And that gives me that a is equal to minus 11 over 7. Or a is equal to minus 2 by minus 1. Minus 1, a is equal to 1 when you pop that into your calculator. So my two sets of answers, a is equal to minus 11 over 7 and b is equal to 2 over 7. That's one pair. Or a is equal to 1 and b is equal to minus 1. That's my other pair. Okay, these are tricky. They take a little bit of practice. But I think we've kind of hit the kind of tricks they can put in there. Okay, they can't make them much harder than that. I think particularly this 2016 question, if you can understand that, work through that nice and slowly, then you have a fairly good grasp of not only simultaneous equations in algebra, but also of your fractions, your squaring brackets, your minus b formula, and everything else involved. Okay, so today, what do we do? We did very quick revision of your junior cert simultaneous equations, and then we'd hit the two new types of simultaneous equations that can come up in your leaving cert. So when there's 3, and when you have a linear and a nonlinear. They are very different types. The method is completely different, so do not get them mixed up. Learn how to recognize when to use which method. Okay, I hope you found this video helpful, and best of luck with your practice of these.